Hello team, in this video we're going to look at how clusters provide even more advantages to cloud providers. So we've seen that the Power Wall induced the move to multi-cloud processes, and then the companies these days they tend to centralize their IT infrastructure into a cluster. And this provides many economical benefits. It reduces operational and capital expenses. These clusters require less human resources to manage. Companies can negotiate better quantity discounts by buying many components or many servers at the same time. These clusters have less heterogeneity, which makes them easier to manage. And the clusters, they drive automation and they also make automating tasks easier. Now, cloud providers potentialize these advantages. So a cloud provider hosts multiple tenants, so it has multiple customers using its computing infrastructure. So cloud providers, they build very large data centers to handle computing for multiple companies. And the assumption is that if a company needs additional resource, it can just ask for these resources to the cloud provider. So the cloud provider usually has spare capacity to absorb this increase in demand. So cloud providers, they buy thousands of each component at the same time. And this allows them to negotiate quantity discounts. It might actually be the case that the vendors, they want to sell to the cloud providers just because they're going to be so big of a customer. Say, a chip manufacturer might just reduce its price significantly so that it gets that customer. It's going to be like a huge sale. The cloud providers, because their infrastructure is so large, they have so many devices, they need thorough automation. Otherwise, the infrastructure basically gets impossible to manage. If you have 10,000 servers, you can't deal with each server at a time. You have to automate tasks. So there's a lot of automation, which reduces operational expenses in the end. And the cloud providers, they have standardized processes for handling the infrastructure. So the cabling is well structured. It's easy to observe when there are failures. When a disk fails, for example, there may be a standard process for turning the server off and then taking the disk out and then putting the new disk in and then restoring the RAID, like the backup on the disk and so on. So these processes might be all standardized, which again helps reduce costs. One thing that cloud providers need is to isolate tenants. So the performance that a tenant, a customer gets must not depend on whatever other tenants are running. So if another tenant is running some very heavy computation, your machine, your device, your virtual machine on the cloud must not be impacted in any way. And also, each tenant's data and code must be kept safe and separate from other tenants. So if you upload data to the cloud, you don't want anyone else accessing that data. Now, cloud providers potentialize these advantages. So a cloud provider hosts multiple tenants, so it has multiple clients. And the assumption is that if a cloud provider customer needs additional capacity, it just needs to ask for the cloud provider. So the cloud provider might actually have spare capacity to absorb this increase in demand. So cloud providers build very large data centers to handle multiple customers. So they buy thousands of each component at a time, like thousands of servers and chips and switches. And thus they get significant quantity discounts. So if a company has the opportunity to sell 10,000 servers to Google, it might actually reduce the price of each server that it gets to make this huge sale. Also, because these data centers are so large, cloud providers have to develop mechanisms to automate many tasks. Say if you have 10,000 servers, you can't handle software like upgrades or installing servers because there's just too many. So the cloud providers, they automate a lot of tasks. And they also develop standardized processes, probably very integrated with automation for many tasks. For example, deploying new service might be an entirely automated process. Some person is going to plug the server into the rack, and then maybe no one needs to push a button. Sometime later on, say midnight, a automated process will detect that a new server has been plugged in. It has not been installed yet, and then it might just install the server from the network. And then next day, the server has an operating system installed and becomes available for cloud customers. And so no one had to configure that server, it just happened automatically. And similar processes might be developed for replacing parts. Say if a disk fails, then there may be a time of day where one technician goes and takes all of the disks out of the servers, and then some other technician replaces them on the next day, and so on. So these automated and standardized processes makes everything run more smoothly and in the end much cheaper. Here we have a picture of Facebook's Fort Worth data center close to Dallas. So this is just to show you how big these data centers are. So here we have a truck for scale. So in this building here is mostly, computing equipment. And it's expanding. So they, this construction of a new building over there where they're probably going to put even more servers. So this is, a lot of computing capacity at a single location. And on the inside, this is what it looks like. So we have these rows and it's full of racks and then cabling to interconnect everything. And it's mostly standard. So you see the racks that all look the same. So it ends up being much easier to manage at the scale that they build these data centers.